In this third part on coordinate transformations, we are going to go a step further and talk about successive transformations. But before we do that, let's just quickly revise what we learned in the first two videos. We learned this formula, which is big X equals ax plus d, where d is the coordinates of the moving frame with respect to the fixed frame. The A is the rotation matrix, which is given by cosine theta, sine theta, negative sine theta, cosine theta. X is a point which is expressed in the moving frame. And the big X is the same point which is now expressed in the fixed frame. Now coming to successive coordinate transformations. In successive coordinate transformations, the fixed frame is displaced and rotated a number of times. So there are a number of moving frames present. Here let me draw out the fixed frame first, which is F, and now I draw the d1 vector, which is the displacement of the first moving frame, and then I rotate the moving frame by an angle of theta, which I call theta 1. So right here I get the first moving frame, which has been first displaced by a vector d1 and then rotated by an angle theta 1. So theta 1 is the angle between the fixed frame and the moving frame m1. Now I draw another displacement vector, which is d2, which is now expressed in the m1 frame, which takes the m1 and displaces it by d2, and then it rotates it about an angle theta 2 in an anticlockwise direction. Notice that theta 2 is the angle between m1 and m2. Now I have a point which is defined with respect to the moving frame m2, and its coordinates are given in the vector small x, and I need to find the coordinates of the same point in the fixed frame marked by capital X in red. So I am going to go step by step. First I am going to define the small x in the frame m1. So I'm going to define the small x in the moving frame m1. This I have marked as the vector y. In order to find y, I again use the same formula, a2x plus d2. Notice that I have used a2 since the angle is now theta 2, which is the angle between m1 and m2. So now I know the vector y, which is the point defined in the m1 frame. Now I just need to take this point defined in the m1 frame and define it with respect to the fixed frame. So I again use the same formula, which turns out to be a1y plus d1. Here the angle is theta 1 and the displacement vector is d1. Now instead of y, I input this equation, and simplifying it further, I get the following. Big X equals a1 a2x plus a1 d2 plus d1. Now let's take a moment to understand what this equation actually means. We can start out by dissecting this equation, starting with the term on the rightmost, which is d1. So d1 is just a displacement term. What it does, it takes the fixed frame and it displaces it by a vector d1. Now the term next to it, a1 d2. We know that d2 is the displacement term again, but it is expressed in m1. So in order to express d2 in the fixed frame, I simply multiply it by a1. So a1 d2 is actually the displacement term which is now expressed in the fixed frame. So these two terms combined, a1 d2 plus d1, actually gives me the displacement vector which takes the fixed frame and places it at the final moving frame m2 with no rotation involved. Now if these are the displacement term, then a1 a2 must be the rotation matrix, and it is. So a1 a2 combined is the rotation matrix, and it is the matrix that makes the moving frame rotate about angle theta 1 and theta 2 combined. I know this might be a little overwhelming, so try pausing the video and just making sure that you really understand this before moving on. Now let's focus on the a1 a2 term, which is the rotation matrix. So let us investigate the A1 A2 term further. If I write the A1 A2 matrix in the expanded form with A1 being a matrix of theta 1 and A2 being a matrix of theta 2, I get the following matrix. Now making use of the two trigonometric identities, which are the sums and differences of the cosine and the sine functions, as follows. Making use of these two trigonometric identities, I can simplify the A1 A2 matrix down into a matrix which has cosine of theta 1 plus theta 2, sine of theta 1 plus theta 2, minus sine of theta 1 plus theta 2, and cosine of theta 1 plus theta 2. So now you can compare this with the original rotation matrix that we wrote, which had cosine of theta, sine of theta, minus sine of theta, and cosine of theta. And simply by comparing, you can see that wherever there is a theta in the A1 A2 matrix, there is a theta 1 plus theta 2. So the angles of A1 and A2 are simply being added together, which is quite intuitive, right? Let me go up, and here from this figure we can see that the frame M2 is simply rotated with respect to the fixed frame by an angle which is the sum of theta 1 and theta 2. Now let me take it up a notch. Now there are three successive coordinate transformations happening. So there are three moving frames, M1, M2 and M3. So each would have its displacement vector d and its rotation angle theta. So the displacement vector d2 is expressed in the m1 frame, and theta 2 is the rotation angle between m2 and m1. Similarly, the displacement vector d3 is the displacement vector which is expressed in m2 frame, and theta 3 is the angle between m3 and the m2 frame. Now I have a point small x which is expressed in a m3 frame, and I need to find its coordinate in the fixed frame, which I have marked in red as the big X. So the question is, how do I go from the small x to the big X? I would encourage you to pause this video right now and try to see if you can come up with the solution. I hope you did give it a try. Don't get disheartened if you don't get it on the first try, but I can write it directly as the big X is equal to a1 a2 a3 small x plus a1 a2 d3 plus a1 d2 plus d1. Here the last three terms are the displacement terms, which just tells you how much the fixed frame needs to be displaced in order to reach the M3 frame without changing its orientation. And the A1, A2, A3 combined is the rotation matrix, which tells you how much the fixed frame needs to be rotated about in order to reach the M3 frame. So it's not surprising that when I multiply A1, A2, A3 together, I get a matrix which is of the same form as the rotation matrix that we discussed before, which is cosine theta, sine theta, minus sine theta, cosine theta. But instead of theta, I am getting the sum of theta 1, theta 2, theta 3 as expected. This brings us to the end of the third part on coordinate transformations. If you like this video, don't forget to subscribe. If you have any questions, leave them in the comment section below. And see you in the next part, in which we apply all of this to robots.